This lesson is going to be on stoichiometry. And just to remind you, stoichiometry is more or less like cooking something, where if you have a certain amount of ingredients, it makes something. In one case that we'll be using the example, I'm going to make the example of a s'more. For s'mores, you have 2 crackers, 1 marshmallow, and 1 piece of chocolate to make 1 s'more. All right. And if you happen to have 2 marshmallows, let's say we have 2 marshmallows, we can figure out based on that, using stoichiometry, how many crackers we need, how much chocolate we need, and how many s'mores it will make. So in this case, with 2 marshmallows, we know we need to have 4 crackers, double the amount. We need to have 2 pieces of chocolate, which will make 2 s'mores. We figured this out, and that we saw how much more or how much less we have of something. So to do that, you always place what you have on the bottom, or what you require, my apologies. And on the top, you write down what you have. So let me move that further down. We know we have we require 1 marshmallow, but in fact, we have 2. So in that case, we know we have double the amount, okay? And then I'm going to take this number and double everything, times it by 2. So 2 times 2 is 4, 1 times 2 is 2, and so forth, okay? And we can do that if we also have less than that. So let's assume we only have a half a marshmallow. And again, we're going to look at our original recipe up here. If I have half of a marshmallow, I can still make a s'more. In this ratio, I need to have 1 cracker though, and I need to have a half a piece of chocolate, and it's going to make 1/2 of a s'more. How did I figure this out? Same idea, is I figured out what I have, and I knew that I have half of that. So that works out to be that I need to multiply everything by 0.05. So we can even take it one step further. Let's say, for example, I have 0.362 of a marshmallow. And do the same idea. How much of a cracker do I need? How much chocolate do I need? And how much of a s'more is it going to make? So I take this number. This is what I'm given. That goes on the top. So I have 3.362 marshmallows. I need 1 marshmallow. And so that works out that I need to multiply everything by 0.362 to get the right ratio. So if I do that, that means I have, if I do this in my head, 7 to 4 of a cracker that I need, and I have the same quantity, 0.362 of chocolate, because it's a 1-to-1 ratio, and I'm going to get 0.362 of a s'more. Okay, so we're using the same technique. Now let's actually just add the chemicals to this here, and we'll do that by using one example. So one example that I'm going to have is going to be a combustion reaction, and I have C3H8 plus O2 reacting to be CO2 plus 4. Actually, I'm gonna erase this and have us balance it together. This part right here. Okay, so you're given this reaction, and now what you're going to need to do is you need to figure out, based on a quantity, how much you have of everything. So the first thing is we need to balance the equation. So if I were to balance it, I take a look. Remember, we start with carbon first. I have 3 carbons here. I need 3 carbons there. Then for the hydrogen, it looks like I have 8 here. So I need to have 8 here. And now I'm going to make my oxygens work, and they work out if I just put a 5 here. So that means that for every propane I have, that I need 5 every mole of propane, I need 5 moles of oxygen, and it's going to produce 3 moles of carbon dioxide and 4 moles of hydrogen. So let's assume what happens if I have 2 moles of propane. Well, in that case, you probably will quickly realize that that means that you need to have 10 moles of oxygen, 6 moles of carbon dioxide will be produced, in addition to 8 moles of water. Let's do one where we have maybe half of that. So in this case, I have 0.5 moles of propane. So in that case, I take this number and I realize, oh, this is half of the quantity. I need to make this 2.5 moles of oxygen, this 1.5 moles of O2, and this here 2 moles of water. Okay? And we can continue on with a number like we used before, 0.372 of C3H8. Same idea. We take a look at how much of a difference we have, and I look and I say, oh, okay, looks like what I need goes on the bottom. I need 1 mole of C3H8. I'm given 0.372 moles of that. So I need to multiply everything by 0.372 to get my number. And so when I do that, I take my oxygen and I punch in 2.5 times 0.372, and it works out to be that I need 0.93 moles of O2, and produced, my apologies, is that I have for every 1 mole of propane 3 moles of carbon that are produced. So I take my number 0.372 and I times it by 3 because that's the ratio. Okay, and it looks like I need to make sure that my numbers are correct. And I have for this one 1.12 moles of CO2, and this one here does not look like I have it correct. I think I only multiplied it by 2, so let me change that to 0.372 times 5. Yeah, this one should be, my apologies, should be 1.86. I did a calculation mistake. And for this one here, I would take my 3.72, multiply it by 4 to get 1.49 H2O. Okay? So, this is the general gist of it. We're going to then add grams to it, but let me show you how we can actually do this using dimensional analysis, which will be easier for some people. And here's where I work in the grams as well. And the idea is this mole tunnel. So you have your mass here of A. And that's going to then need to be converted to moles of A. Once you have the mole of A, you get the ratio of A to B. So that will get you your moles of B. And from moles of B, you can figure out your mass of B. So let's have example. Let's say we have back our equation that we had before. We have propane, which is C3H8 plus 5O2, reacting to make 3 moles of carbon dioxide and 4 moles of water. Suppose you're given 96.1 grams of C3H8, and we want to know how many grams of O2 we need. Okay, so this is what we're given. This is going to be what I'm going to place right here. This is my mass. Okay, so the first step is I need to get to figure out how many moles that is so that I can look at my ratio. So I do a quick dimensional analysis, 96.1 C3H8. To get it to moles, remember it's simply the dimensional analysis we've been using the whole time. And if I look at my periodic table and add up 3 carbons and 8 hydrogens, I see that I have this being my molar mass over 1 mole, C3H8, which works out to be, by chance, 1 mole of C3H8. Okay, so that's what I'm going to place over here. So here I know I have 1 mole of C3H8. I have to go back to my equation to see how many moles, for every 1 mole of C3H8, I make 5 moles of oxygen. So it looks like I'm going to create, with this quantity, 5 moles of oxygen based on this, because I need to take my number and times it by 5, and I use my equation to figure that out. So in this case, it's an easy calculation. It's 1 times 5 equaling 5. So in that case, now I have my moles of oxygen. I now need to convert my moles into a mass. So I take 5 moles O2. And you notice I have O2 here because we actually, in this case, will keep them as they are in the equation. And I know that I have 32.00, excuse me, I have, for every 1 mole of O2, I have 2 oxygens. Remember, because I have 2 oxygens, each one weighing 16 grams, each mole, I now have 32 because I have 2 of them. And that gives me an answer of 160 grams of oxygen. So that is my answer. How many grams of oxygen do I have? I have 160 grams of oxygen.